What I'm going to talk about today, it's a fairly, as I said, a condensed version, but we're going to cover a few things. We're going to talk about specifically how I ended up working in this space, and there's a little sort of an interesting story there about my career journey and how I ended up talking about attack simulation. We'll talk about attack simulation, which has been covered a fair bit today already, but I want to give you my perspective on it. I want to explore how Splunk does this as an organisation, how we do this internally, and also how some of our customers are doing this with some of the open source capability that we've published, and then a practical application about how it actually works. Quick question for the audience. How many here are using Splunk today in your environment? I know a fair few are, but anybody want to put their hand up and admit that they're using it? Yep, okay, so a decent number. So I would say that don't think if you're not using Splunk that this is not worth paying attention to. What I'm describing is a methodology that does have some Splunk specifics in it, but is very applicable to non-Splunk environments. So I think this is relevant, and what we're putting out there in the market in terms of our open source capability is worth taking a look at. So I'll jump right into a tiny bit of background on myself. So I counted, and I think it's about 17 years of experience. I'm suddenly starting to feel slightly older than I did when I added that up. I kind of wish I hadn't. But I've done all sorts of things in the security space, but also in the infrastructure space, in building large computing systems before I sort of started dabbling in security. I tend to focus on what I would describe as highly targeted sectors. So I work a lot within federal government in Australia, but also around the region as well. The financial services sector, so lots of banking in Australia, the superannuation industry, and then the healthcare market as well. I came across attack simulation. I was certainly aware of it, but I hadn't really ever done much in concrete terms until a little bit over a year ago. So I was going through the job application process at Splunk, and one of the things that you have to do as a technical pre-sales person coming on board is you need to do a demonstration of a platform, and you need to build out some use cases. You need to generate some data, build some dashboards, show how you detected. In my case, it was a security role, so detected some security events. I had a decent amount of Splunk experience, but we're talking 10 years ago, so fairly dated. I needed to rapidly skill up. I needed to rapidly learn the platform again. I needed to rapidly generate some data. I needed to rapidly, I guess, fail fast, you could say. I needed to be able to spin it up, tear it down, do it repeatedly so that I could get to the point in a very short amount of time that I could demonstrate the platform to the person who would hopefully be my boss. As it turns out, I got the job, so it worked. But basically what I discovered was some open source capability that's out there that I think is probably Splunk's best product that we make that isn't actually a product. I'll talk a little bit more about it in a second, but it helped me skill up very rapidly. And I think that's a bit of an example of how a lot of the new players in the cybersecurity industry could potentially use some of this capability, whether it's from Splunk or from others. But attack simulation is a great capability that's allowing us all to collectively lift our security posture, but also allowing new people in the industry to learn quickly. So I think there's a lot of potential benefits there for all of us. I think we probably all know what attack simulation is by now. We've talked about it a bit, but I'll just give you a tiny little perspective on it. So it is, in essence, to use attack techniques against a network, against a system, or against a process. So it doesn't necessarily mean against a computer system. It could be against an organization's processes, their people. I'll give you an example of that in a second. And it is specifically done to test the defenses and then to iteratively improve those systems. So we want to collectively start to improve the security posture. It is, of course, part of a threat-informed defense, and I would argue an assume breach mindset as well. And ultimately, we're doing it with the intention to improve the security posture, but also to improve our knowledge, our individuals' knowledge, the knowledge of the organization as a whole, the knowledge of the industry. An example of attack simulation that I think we've all probably been subject to in our organizations would be a phishing email. The phishing campaign that comes out on a fairly regular basis, I get them. I got one fairly recently, didn't fall for it. But this is ultimately, I would argue, attack simulation. It is attacking our users. It is going after them. This has been around for a long time. It's improving and it's iterating over the years, but this is one example of it. If we have a look at how I think attack simulation and MITRE together can help you, we've covered a fair few of these today, and I've heard different lenses on this. My perspective is ultimately this attack simulation capability, being able to break it down into bite-sized chunks rather than having to necessarily wait for a large red teaming activity, those sorts of things. It's going to allow you as an organization to help level the playing field. So by that, I mean the new people in the team, the graduates, the level 1 SOC analysts who previously didn't have access to very detailed threats on the environment. We don't want to have to wait until a nation-state actor comes onto our network to have to learn how to defend against that, so we can simulate it. It allows us to be proactive. We can put our hand up and say that we want to improve and we want to actually start testing things. How do we do that if we don't do some attack simulation? Again, exposure to diverse threats in order to develop skill sets and do things like threat hunting. By the way, a little plug for a thing called the Peak Threat Hunting Framework. I heard it mentioned earlier today. It's something that Splunk has recently put out there into the market. A fellow by the name of David Bianco, who's been mentioned a lot of times over the last 2 days, now works at Splunk. He was a key author of the Squirrel and the Tahiti frameworks and the Pyramid of Pain. He has recently, amongst a whole lot of others that have contributed as well, pushed out the Peak Threat Hunting Framework. So it is vendor agnostic. It does not at all assume that you're using Splunk. So if you're using any other security capability and you are interested in threat hunting, have a look at the Peak Threat Hunting Framework. And ultimately, of course, consistency and common language is a key benefit that I think we can all agree with. So, a couple of tools. Now, by the way, I did this slide about a little bit under a year ago, and well before I was aware of this conference. And so the links that I put up there is not because I'm at a MITRE conference. I actually happen to have used a lot of these tools, and a lot of the capability that we use does leverage Caldera, by the way. So there's 4 that I've picked. There's a lot more than 4 that are out there. 4 that I have done a lot of work with customers on recently. The first one is the one that I'm going to talk about. It is an open source capability that Splunk has published called Attack Range. It is not a product. I can't sell you Attack Range, but I can let you go and download it and run it, and I can talk to you about it. There's a lot of other capability out there as well, so I'm certainly not claiming that ours does everything, but I would encourage you to, of course, do your own research. But I'm going to talk about Attack Range. So, how Splunk does this internally. So Splunk is a large organization, now much larger because we are part of Cisco. And Splunk, the slide's gone a little bit funny there. It's meant to say build, simulate, and test, but use your imagination. The challenge that we had, like a lot of organizations, was we have lots of detections for lots of things that are happening. And we wanted to, and by the way, a lot of those detections, of course, get published out to you good folk as part of your platforms if you're consuming Splunk. So we had the requirement to test them on a regular basis to validate that they were working. So internally, there was some soul searching going on. We looked at buying products. We looked at gluing a whole lot of things together. In the end, we ended up building something ourselves, and we've now donated it out to the community as an open source project. In essence, Attack Range, what it does, it is a bunch of scripts put together, released under an Apache license, which will allow you to do 3 things: build, simulate, and test. Build meaning it builds a lab in AWS, in Azure, on a local virtual machine instance, wherever you want to put it. It will build a Splunk environment for you. It will build a Windows server. It will load Active Directory onto it. It will populate the Active Directory domain with objects. It will put a Splunk Universal Forwarder, our agent, on that infrastructure, and it allows you to simulate attacks. So I can specify whatever MITRE attack, whatever MITRE TTP I want to test, I throw it at Attack Range, and it will perform the simulation for me. The Windows server, the Linux server, whatever it might be, will detect something, hopefully. The logs will be ingested by Splunk, and we go through a process of detection engineering, of testing, to see whether we would have actually picked up the thing, the particular type of attack. It is at its heart, as I said, of course, a bunch of times, an open source solution. It's ultimately Terraform doing a whole lot of the heavy lifting. There's some open source binaries underneath and packages underneath like Caldera that you'll be familiar with, Atomic Red Team, as well as we can plug into some commercial off-the-shelf offerings as well to do some attack simulation capability. But it is fairly powerful. Now, what I'm going to show you is how it would work in practice, and this is based fairly closely off what a customer of mine in Australia is doing and how it works in their environment. So in essence, if you think of yourselves as having Splunk, now maybe you don't have Splunk, maybe you have Sentinel, maybe you have something else. This is, I think, a fairly agnostic view of how this could work. But in this case, it's a Splunk environment that you have today in your environment, and it's doing lots of things. It's detecting bad stuff on your network. It's sending alerts. The SOC team is handling them. All is good. But one day, someone asks a difficult question about what about the unknowns? What about the TTPs that we've got, that we've written detections for, that we've never seen fire on our network? We have absolutely no idea. Is that because we've never had that thing happen? Maybe we don't have the right data being ingested. Maybe our detections are no good. We have no idea which one of those it is. So we then start to have a bit of a think about, well, how are we going to do this? So we want to know those unknowns down there. We want to be able to test them, right? Now, historically, this has been done by some very smart people who will go and build some infrastructure manually. They'll build a Windows server. They'll build Kali Linux. They'll go and do a once-off point-in-time detection test. Maybe there'll be a red team activity that will come along, perhaps on an annual basis, maybe more frequently, depending on the type of industry that you're in. But that's a fairly big undertaking and not very repeatable. So what we want to do as part of this is to make it bite-sized, make it iterative so that we can do it rapidly. So in my example, what we then do is we go off to, that might look familiar, that's a Splunk application with the MITRE ATT&CK view of the world in it. By the way, if you're a Splunk customer and you're not using Splunk Security Essentials, it's a free app. Make sure you go and get that, because that's what that is. It will help you benchmark where you are and see what detections you have and don't have and all those sorts of things. But in this example, what you would do is you would say, well, okay, for the detections that I've written and I've never seen them fire, I want to go and understand, I want to go and look them up in the MITRE ATT&CK view of the world, and I want to perform a test. So what I do is I grab my TTP, I go and give it to, that's the attack range logo on the right-hand side there. I literally type in the command line, I want to test, in that case, T1547.001. I don't remember what that is, but maybe some of you will have them memorized. I want to test that detection. What it will do is it will fire up, it will build a lab, maybe it's already built the lab or maybe it's building it for you now, but it will go and build the lab environment, which could be anything you want it to be. It could be 100 Windows servers, it could be one, it could be Kali Linux, it could be some combination of all of those. It could be in AWS, it could be in Azure, it could be on a local instance. You've got the logos for Atomic Red Team and Caldera. There's a whole lot of other options as well, which I don't have time to list, but there are others that we can plug into. And of course, again, open source, you can plug in whatever you want underneath if you would like to. But it will fire up a test. It will send it off to the Windows server, the Linux server, the whatever it might be, which of course has a Splunk universal forwarder on it, an agent in essence. So the logs get ingested. We send it back to the Splunk environment with the view ultimately to do that, to start to track over time how many of these things that we're testing are we detecting. Hopefully we eventually get to the point that that's going up and up and up and up. We start to report this over time. This, by the way, if I can hopefully go back one slide, this is an example of how this might look. Another example would be, and that, by the way, up the top left-hand side there, that Splunk instance, in this conceptual example, it is your live production environment. But of course, Attack Range can build a completely isolated Splunk environment for you as well. So we can do that, and any combination of all of those could potentially work in this sort of a setup. So ultimately what we're trying to do, the ultimate aim here is to start to track this so that this number goes up. So that every time we perform a test, hopefully we are performing detection engineering as well, so that our percentage of tests that we're performing is starting to go up. This is another conceptual view of what it would look like. If we start there on the left-hand side, the top left there, we've got a threat feed. So we have some information about the types of things that are targeting us from whatever source that might come from. We then take that and we give it to our attack simulation automation platform, which would in this case be Attack Range. We perform the test. We go down there on the bottom right-hand side, we have to build or refine the detection. So if the test worked, great. Not a lot we need to do other than to record it. If it didn't work, we go through a process of detection engineering. And there's a whole thing that we can talk about there. But you would go and do some detection engineering to make sure that the detection works. Maybe you're bringing some more data on board the platform that wasn't there before. Maybe you're correcting the search, whatever it might be. And then I think really importantly, detection reporting. So actually recording and tracking over time how much of this stuff is being correctly detected out of the gate, how much detection engineering effort is being required, what is our percentage of tests that we're firing at the system that are being detected. Obviously, hopefully we're going up over a period of time. We've got heat maps, we've got all that sort of stuff. I know there's a little bit of debate about heat maps, but we've got them if you want to use them. I think they're a tool in the toolbox. I don't think they are the ultimate answer. But I think they are still potentially quite useful. This is my last little plug for an app that's in the Splunk base. If you've heard of that, it's free, so you don't have to pay for it. But if you're using Splunk and you don't have this, go and get it. It will give you things like the MITRE ATT&CK view of the world based on your data, what's in your environment, what's not in your environment, where you have threat actors targeting you, that you don't have any detections enabled for, those sorts of things. Really powerful capability. And totally free. So definitely suggest you go and get it. I think ultimately to kind of summarize, this is a free capability. If you are in the industry or you work with people that are in the industry that are looking to skill up, they want to have exposure to diverse types of threats without having to do the heavy lifting of building a Splunk environment, of standing up the Windows servers, of loading Active Directory, doing all of that work. I think that's still important, but you don't need to do it every time. If you want to rapidly get to that point where you're practicing, you're learning how to do threat hunting, you're learning how to do that threat identification, this type of a technique, whether you're using Attack Range or some of the others that are out there, of course, I'd love for you to use Attack Range, but I think it's very powerful for a lot of the organizations that I'm working with in Australia. So we've got banks that are using this, we've got federal government departments that are using this. it is baked into their detection engineering process. So as they go through and start to do detection engineering, they are automatically, through a pipeline, they are firing tests at their Splunk environment and validating that it works. It's a key component of how they're doing detection engineering. And I think it's definitely something as an approach that could collectively help us all. That is, I think, everything I had, and hopefully I finished in good time. 2 QR codes, one with my face is me and my LinkedIn, so please add me. The other one is attack range. So if you have any interest in looking it up and you want to do a bit of research, it's on GitHub, you can go and download it. Up the top right-hand side there, get that QR code. And if anybody would like to talk about it in a bit more detail afterwards, I would be very happy for you to come and grab me.